Okay, are we recording? Yes, we are. All right, so this is going to be a continuation of the NRF24 demo I did a while ago. This is just to demonstrate how to send and receive data from two identical units. There's a couple of changes I need to do to the code that I forgot to do on the original demo. So I don't know if it's a bug or not. I know I left a line of code on two functions out by mistake, but there's also a timing bug according to the documentation. So let me show you what I have. So those are my two identical units. They're connected exactly the same, two different boards. The connections, as you can see on the screen, we have the master in on GP12, 11 is master out, and the 14 or GP10 is the clock, and 9 will be the chip select. I think it's chip select, and then no, not the chip select, but I don't remember what it's called, CSN. And then on 8 is the CE. This is the one for sending and receiving data. The other one is just for enabling communications through SPI. And we have ground and 3.3 volts. So that's what we have here. The connections are exactly how you see it on the screen. So we have it on pin 16 here, which is the same here. So we have the master in, master out, CSN, and don't be confused by the coloring of the wires. That's just what I have. CE, and then I'm sorry, master in, master out, the clock, CSN and CE, and then on the back here we have the volts, 3.3 volts coming from the Pico, and ground. And this is the same thing. I also have connected two pins. Will be number GP15 and GP16. Let me switch to the data sheet right here, and actually let me show the whole thing. So we have this one, GP15 or pin number 20, however you want to call it. We're enabling that pin for input for a push button, and we're doing the same for GP16. So 15 is going to be for sending a message telling the other unit to turn the LED GP25, this LED, to turn it on. And this one, GP16, when pressed, is going to send a message to the other unit to tell it to turn the LED off. And both of them are going to communicate between each other, so both of them are going to control the other's LED to turn it on and off. So we're only connecting two additional ones, so it's GP15, GP20, I mean GP16 and GP15. And the buttons are connected through a 1K resistor. It goes directly to the pin to keep it high, and when the button is pressed, it's pulled to ground. So it'll be at 3 volts, and when you press it, it'll be at 0 volts. Same for this one. So both of them are identical. Connections are exactly the same. The voltage is coming through this resistor, going to this wire to pin 16. When you press the button, it brings the voltage back to this wire to ground. Same with this one, voltage coming from this resistor, going to this leg of the button, coming through here to GP15. When the button is pressed, it closes the circuit to go to ground. So that's what we have. Let's take a look at the code. Let me switch. So this is the same code from the NRF demo. Nothing has changed. It's exactly the same. So we're just gonna continue where we left off. So first, we're gonna go in and take care of the two issues. The first one is that in this mode, I forgot to set the CE to low and high. So according to this, to the flow, um, if you are going to set it to receiving mode, then CE has to be high, and vice versa. If you want to have it as transmitting mode, then you have to have CE as low in order to pulse it to high. So for receiving, it's going to be high. So this is receiving. And right here, we're going to say CE high. So that's what I forgot. Okay. And on this one, CE low. Okay. And let's just verify a second time. So for transmitting is low, for receiving is high. And this one is explicit. It says it has to be high. On this one, it doesn't say it has to be low, but it says that you need to have it high for at least 10 microseconds. So in order to have it high, you have to have it low, right? So that's the assumption we're making. Okay, so low for TX and high for RX. So on the testing that I did after I published the first video, I've noticed that if you switch channels, if you switch modes really fast, it's not able to send messages sometimes. Where's the send message? Right here. So it requires a bigger delay, and I couldn't find it in the documentation other than pulse it to like 10 microseconds. But I found that it has to be 300 microseconds to reliably send messages all the time. Or you can check to see if the output buffer has data in it, and if it does, then you just wait until it's done. But this is required if you're going to be switching modes back and forth. So the idea here is that we are going to have the units always listening to messages and switching modes to send a message whenever you press a button. So let's do that right now. We are going to just comment this whole section and do a new one just so we don't mess with this one. So we'll start with the main and have our while loop and return 0. Okay, so we're just gonna redefine the NRF, which is pretty much, we're gonna do similar to what we have down here, and we'll call it NRF as well. We need SPI1, and the pins, one, it requires CSN and CE, and where is that? We said that CSN and CE are 9 for CSN and 8 for CE, which is what we have here. All right, so 9 and CE, it says right here, is 8. Okay, and right from the start, we're going to configure it, and we're going to set it to receiving mode to receive data. So that will enable us to receive data. The other thing we're going to do is we are going to enable this pin, LED, as output to turn it on and off. And we are going to enable this pin, 15 and 16, as input, so we can check the status to see if the button is pressed or not. So GPIO init 25, and then we'll do the same for the other two, 15 and 16. And we'll set the pin direction. So set direction for 25, we say it's going to be output. That's a 1, or you can say GPIO as output, out, right? We're going to leave it as 1. And then we do the same for the other two. The only difference is that they will be 0 for input. Okay, 15 and 16. We also need a buffer, so to send and receive data. And we're going to do two buffers just so it's clear what's happening. So we're going to say buffer out. It's going to be 32 bytes. And it's not going to have anything. And then another one for buffer in, 32 bytes as well. And in the loop here, we're going to check if any of the buttons are pressed. So we said 15 was going to be for turning it on and 16 for turning it off. So we'll say if uh, GPIO, what is it? Get? Yeah, 15. So since we have the pin pull high to voltage, it will always return a 1. So we want to check to see when it's not on, right? So we'll just say the opposite. This returns a Boolean, so it will say true or false. So we want it when it's not true, when it's false. So we'll just reverse it. And if it's that, then we will switch modes. So NRF, we're going to switch to transmit. And then we'll copy the message into the buffer out. And we'll say on. Then we can send the message, buffer out. And once the message is gone, it should be print, not print, it's print. We need to change the mode to receiving again. So we go back to receiving data. Else, if GPIO get 16, this is the one for turning it off. So here we'll do pretty much the same thing. And difference is that it'll say off. Okay, so when we press this button, it'll turn the LED on the other unit as on, and it won't turn off until we press this other button. Okay, so now we also need to check if any messages are coming in telling us to turn on or turn off the LED on our unit. So here we'll say if NRF new message, and by the way, we created this class on the previous video from scratch, so you can go watch that video if you want to see what it does. If it's, what is it? If it's 1, I think. What does it return? Yeah. All right. So if it's 1, then we have a new message. So here we can compare strcmp. Well, actually, we need to get the message. So NRF receive message, and it'll be the buffer in. So, and then we can compare whatever we have in that buffer in against on. So if it's on, I will say GPIO put 25 equals 1. So turn it on. Turn the LED on the GPIO 25. Else, if str compare buffer in off, then we'll say GPIO put 25 0, right? So pretty much turn it off and turn it on. Okay, let's complain about this one because we haven't included a library for it, so let's do that. And it will be the string, and this should go away. There it goes. So let me compile this, make sure there's no errors. Okay, so seems to be okay. Let me make the code a little bit bigger so you can see it better. So there it goes. So we're starting here from string, created all of this stuff up to that one. So what's going to happen now is going to loop here. Let me make it slightly smaller. So this is the entire loop. So every time it loops, it's going to check to see if this button is pressed or if this button is pressed. And once it goes through those two, then it's going to check to see if we have a new message. And if we do have a new message, we'll go and retrieve the message, put it in this buffer. Then we'll compare that buffer against this message on. If it's on, then we'll turn it on, the LED, the built-in LED on the Pico. Otherwise, if it's not on, then it'll come here and check to see if what we have in buffer in is off. And if it is, it'll turn the GPIO equals 0. Now this needs to be 0 because it returns either -1, 0, or +1. Right? So when it's equal, it'll return a 0. So that's it. Let me compile it. And we'll load it. Let's see. Let's load both of them. All right, let me drop it in. This one's ready to go. Let me do it on the second one. Drop it in. All right, so now let me remove the code from the screen. All right, so there's the two of them. Let me turn it around so we can see it better. And let me connect like this. Connect this other one. So now if this button is supposed to turn it on, that one on, and this one will turn it off. Same for this one, will turn this on, and this one will turn it off. So this one controls that one, and this one controls this one via the NRF. So let's see if it turns on. There's the LED is on. I can turn it off as well, right? Now the buttons are a little loose, so they're not making good contact, so sometimes it might work or it might not. Same with this one. You can see this one turns on, turns off. Pretty simple, right? So let's see. Expand a little bit here. All right. So pretty easy. It's looping, checking to see if GP15 is pressed. If it is, it sends a message to the other unit. And it just changes the mode, loads the buffer, sends the message in the buffer, switches back to receiving mode. The other unit, when this happens, is gonna see that it has a new message. It's gonna receive the message, put it in this buffer. It's gonna compare to see if it says on, turn it on if it is on, or turn it off if it is off. Otherwise, nothing happens. If this one's pressed, then it'll switch the mode again to transmitting, load the buffer with off, send the buffer, switch modes again. The other unit will come here again, see that it has a new message, receive the message in buffer in, compare. If it's on, it'll turn it on. If it's off, it'll turn it off. Otherwise, nothing happens. That's the whole thing. The important thing here is that if you have the download from the previous video, you need to put this on mode TX. You need to set the CE to low. On RX, you need to set CE to high, and increase your timeout to 300 microseconds. So sleep US. That's it. So Go have fun. Enjoy.